Yeah, so I'll show you really the simple features of PolicyMap, but really maybe how people might use it so you have a better sense of the tool itself. And then I'll also explain that we currently have two versions of PolicyMap running at this time. The new version, which is what you see now, and then another version, which we call the legacy version, which is accessible in the very top. So the two are actually mirrored, allowing users to go back and forth. And the reason for that is that we're finishing a couple of things that are being upgraded from the legacy to the new version, and eventually everybody will be on the new version. So we did so much really great development to make the new version of PolicyMap that we didn't want to sit on it too long. And there were so many people trying to use the new features already. So and that's the reason
Okay.
why.
All
But the
right.
new version is perfect. It's a pretty unique. So the way most people use it is a couple different ways. The mapping interface is the bulk of it, which is the map is this pretty simple mapping interface. Users can zoom in and out using the mouse wheel. They can use the little pan symbol on the right. The location bar on the right allows them to zoom the map to a place, either by an address, and then from the address, it'll drop a little pin. And then from that pin, they can still do all the features of, panning around and zooming in and out and stuff. But more than likely, a lot of people use the location bar to search like a Google Maps, allowing you to search to a place. So it could be a zip code, a city, or a county. So we can go to some place like Detroit if we wanted to. And then the map will take us to that region. And so, again, most users coming to the tool, they're definitely using the search by maybe a city or a county or zip code that they're familiar with, probably not always an address.
Right.
The other really neat feature is that the map itself has the ability to make their own boundaries. So sometimes people are working in an area, maybe that area is a containment of roads or maybe other geographies. We call that function a custom region. And so that allows them to make basically their own custom boundaries. So the draw feature is really cool. It's the ability to basically just draw a free boundary on the map. And the first function is this, what we call click to identify. And you're basically just clicking on the map and dropping the vertices of a given area. And users can zoom in, they can pan around.
Cool.
And then clicking on the endpoint will close it in that process. The other, probably more unique way to make what we call a custom region is the ability to assemble, which is basically taking boundaries that exist within our universe. And then from that, they can make a new boundary out of it. So it initially defaults to the current zoom level. And then in this case, it's what is called census tracts, but they can use this menu here to choose maybe more familiar boundaries. And this is based on basically size a little bit. So the smallest geography is in the top as you get larger and larger as you go down a little bit. So if you use like a zip code, then you're just clicking onto the map and you're highlighting areas that you're making a custom region out of. You can deselect places as well on there. Hey, Chelsea. Hey. Sorry about that.
Hey, how are you guys?
Good. How you doing?
Good. How are
Good.
you?
We're just going through some basics of how to use the tool. So let me know if you have any questions. And it is being recorded, so that way you can rewatch this first few minutes that we missed.
Oh, perfect. Thank you.
Yeah, you're welcome. So the assemble is really neat because it is probably a much more familiar way to make a unique boundary, because then they can use other boundaries in the tool like that. And then speaking of boundaries itself, so we talked about these things called tracks and block groups and such. So those are what we call pre-existing boundaries, or that exist within the tool. And you can basically see what the list of types of boundaries we have from this boundary menu in the very top. And this is a really neat way to look at all the various geographies that we aggregate data at. Some are familiar and some are definitely not familiar. And then some are really unique in that they're regional boundaries that we work with either the local municipality or the city or state, and they're processed here. So users can see some really cool boundaries, like maybe congressional districts on the map, or they can see just more common boundaries like zip codes and such. And you'll see some of these boundaries fade in and out, and it's based on the zoom level. So if we zoom out really far, eventually you'll see some of these zoom out based on where we're at. So eventually tracks will move and such.
Cool.
And then the other really neat thing about boundaries is that they also have a little bit of customization with them. So you can remove the label, and you can also change the boundary width, type, and even color and such. So this is really helpful if you're trying to overlay multiple boundaries together. You can start seeing how those things intersect or overlap in that process. And then the last thing that's really cool about the custom regions in particular is that they are listed in each user's account as you make them, but then they also have the ability to be shared with other users, or in particular for our academic users, or what we call the enterprise license, you can actually share it with the entire academic tool. So this actually allows our professors that make a syllabus based on maybe a program or a project, that they can store some of these custom regions they draw in advance for a class to be added to the university's default list. And so that way students can come in and access those boundaries in that process. So there's a couple of things that allows users to do that, and we'll talk about it a little further, but the custom region one is really unique in that process.
Got it.
Other than that, that's kind of the basics of the boundaries. So again, the really big thing is the location is going to zoom the place to where you're looking at. The map boundaries is the ability to overlay those boundaries that you wanted to look at. So, so if you don't want to search for them individually, then the custom region is the ability to make your own boundaries.
Okay, and you can just click on multiple boxes to overlay them?
That's correct, yeah. So if you wanted to show zip codes and census tracts, then you have the ability to show both at the same time. And then this is where the ability to change like the width and the color comes into play, because then you can see how these little tracks sit within a zip code or a ZICTA.
Oh, cool.
Yeah, this is actually we do some sessions that talk about how the census uses geographies for aggregation, and so to do that we talk about this list is really neat in that it shows you the progression of smallest geography that aggregate up to larger and larger geographies. So when we do talk about boundaries, sometimes in our training sessions or even in our academic sessions, we explain the concept of block groups and tracks, and then how these are the building blocks of how the census uses for aggregation. So from this, they aggregate up to tracks, which aggregate up to zip codes, which aggregate up to county subdivisions and counties and metros and such.
Neat.
And then just a very final thing that's more for visual, the part of it itself, is that the underlying maps, which are generally called base maps sometimes, we do give users some ability to customize that, doing some really cool things, like you can do really cool 3D maps, which is neat. And if you zoom in far enough, you'll see building projections. And then this is, again, most of this is for presentation. This allows some professors and some students to kind of talk about the neighborhoods that they're in. You can start overlaying data and see that data in this kind of 3D aspect in that process. But then more importantly, they can also customize the base map further, which is the details that you see on the map itself, things like names and parks and such. So that's the gear function down here. Which allows them to do a couple of things as well, changing the base maps. And this is all for visual presentation. This really allows for somebody to make a map that maybe fits their branding that they're making a presentation for or such. So terrain maps, satellites. Satellites are really cool because they're very detailed. But the underlying maps themselves, the base maps, again, you have the ability to manage some of the underlying details, removing certain things, parks, even roads. So the goal of that is to give somebody the ability to really make that map specific of their use. There are we just added 2 really cool layers in general, things like rail lines as well as bus routes. So this allows somebody to see their neighborhood, and then from there be able to see, there we go, bus routes, which are in red, the local transit as well as Amtrak, unfortunately. So those two lines are combined at this time. But at the very least, they'll be able to see their neighborhoods, see where bus stops, transit stops occur as you zoom further and further. But then finally, probably the biggest part is adding data to the map. And that data is in the categories above the map. And the categories themselves sometimes have a bit of a general meaning to this. We do have a page that I'll send to you later on, which tries to summarize these pages so you don't have to dig too much into them. But hopefully what we try our best to do is put data in a category that makes sense in that place. The one thing I do always point out for users is that we have two types of data that users can interact with. And the first subcategory of every category is what we call a point data set. And a point data set for us is an address-based data set. So these are little icons on the map that represent an address, which is a point for us. So that's what we call an address-based data set. And then the other type of data that is everything underneath that, which is what we call a data layer. And that data layer is the aggregation to various geographies, which we'll talk about in the legend for you. But it's the two things I always try to point out is data layers and data points. Data points is address-based data sets, and then layer is aggregate data in that. And again, the way the legends or the categories work is that the first subcategory is always going to be a point data set in that grouping. So I won't really get into too much detail of the categories. Generally, they all try to group together based on maybe what they're looking for. So demographics is like persons and race and characteristics and such. Economy is jobs and businesses and workforce and such. If the user doesn't want to dig through, there's a lot of data in those categories. They can also use the data search, which is on the left, and that's basically a keyword search. So from this, they can say, I want to look for data with adults with asthma. It'll find all the variables within the tool that have asthma as the keyword. So health insurance, crime data, access to the internet, basic demographics and such. You can just type in various keywords to get there. And so this is a really neat way to look at some of the different types of data you see. Some will have the clear source. So you'll see from CDC. Some, unfortunately, we have a bit of alphabet soup for some of the data sources. But you'll find out that it's, so in this case, it's Medicare data versus just regular adults with chronic conditions and such. So I'll just add one layer data, and we'll really talk about what a layer data represents and how you can do some pretty cool things when it comes to a layer data. So once you add it, you'll know that it comes from the health indicator. It'll just highlight it from you. But the legend is going to be everything you're going to need to be able to read the map. So it's the title of the data in the very top. This little eye icon in the legend, it will give you this longer data description. This is really helpful for people that are trying to better understand the data that they just added, as well as links to the source data. So we have a lot of data researchers come in here, and they usually follow the data directory link or the source link in the legend. And that will take us to our data directory, which is a list of all the data providers in the tool. But the legend is going to be everything that you're going to use to read the map. It's the geography being shown on the map. In this case, it's census tracts. It's the value of the colors. So now it's saying that anything in a dark purple are tracts that have more than 10%, 10.8% in this case, of adults diagnosed or reported to have asthma. And then anything in the lighter purple are the other side of that spectrum, so 8.7% and below. And then the mouse over gives you the value of those places, and then you can actually click onto those places and it'll give you the value of the place itself, but also the benchmark. This is a really neat tool for people to understand how their place is compared to maybe the city that it's in, the state that it's in, such. And then probably one of the most important features is the legend is their tool to be able to customize the map. So right now you can change the years. Some data sets have more years to choose from. Some data sets have it's a stamp for 1 year. You can change the variable, which is really important because in this case, this is the percentage of people that were reported to have asthma. But we can change this to the number of people then. And so this will give you a count. So it's much different now because now we're looking at density of population. So in this case, most of these tracts in kind of downtown Detroit, there's not a lot of people that live there. And so the number of people that actually might have been reported to have asthma is much lower. But the number is also representative of the overall population in that particular tract, which is the reason why we have the darker purple color. And so that's the difference between the two. The percentage is the neat measurement of the overall population of the place that it's in, whereas the number, which is I think a lot of people try to get to because they want to see the raw numbers of those places, will give you a better representation of the concentration of people that might have that value. And then probably the last and really important feature is the ability to make their own cut points as well. So with this, users can click onto this button with edit ranges. And then this allows them to see this pretty cool histogram. It's very helpful in the world of looking at data. What this is trying to do is show the user that while the max amount of people that are reported to have asthma in a census tract was 2,847 people based on the calculations or the methodology, and the lowest is 10 persons. Majority of the tracts that actually have data is on this far end of this histogram, meaning that all the tracts that really have data is on this side. So if you move this out to this very high end, you're not going to have any tracts that really meet that because there's barely any tracks. So the histogram is really helpful in that process because it allows them to really make ranges based on what they're trying to capture, and they can also make their own cut points. So in this case, they can say, they can say, I want 100 people, 200, 250, and 450. And so now this makes the map allow them to show exactly those cut points in that process. And at the same time, they can also isolate the cut points. So that way, if they just want to, if they're presenting a map live and say, these are the places that have more than 450 people that have been diagnosed with or reported to have asthma, this allows them to show that very simple map. Yeah, so the layer, as you can see, has a lot of customizations. And the reason for that is that there's a lot of really neat ways to visualize data. So we wanted to give users all that various ways to control the message of the data in that presentation.
Super useful.
Yeah. All right, let me show you one last thing, and then I'll show you how to print, and then and maybe a couple of analytical tools that you can see. But the other thing that I'll show you is the point data sets, which we talked about, which are address data. And in the case of points, it's probably one of the easiest data sets to explain because they're just that. They're little icons on the map. The icon represents the point data. In this case, these are public schools. The source link will take you to the data directory telling where the school comes from. And of course, each school or each point has a ton of data available for that location. So this is Mary McLeod Elementary School. It covers looks like the regular school. It covers kindergarten through 8th grade, 552 students, the enrollment by class, the demographics of the school. So it's predominantly Black, and then that as a percentage of the overall population. So every school has this information, and it's a wealth of data that's available for each school. And so what we wanted to do is turn much of this data into ways that users can basically filter all the points that are being shown on the map, because like a data layer, when you first load a data layer, you're just basically seeing all the default ranges and the variables and everything. Same thing with points. When you first load a point data set, you're seeing 100% of the points. And the goal of the filters is to allow you to whittle down the points to just a handful of ones you're trying to identify. So schools are really cool. You can actually filter by a variety of different things, from the grades that it covers, the individual classes, the number of students, magnet school, charter school, virtual learning school, and such. But you can do something simple and say, I just want to show middle schools in the map. And so now the map redraws and all the points comes down to just a handful of ones that cover middle schools. But filters are really cool because you can combine filters together. So you can say, I want to see middle schools and high school. So those two groupings are combined. And you can also take filters from other categories. So if you want to find out of these schools that are middle school and high school, maybe ones that have fewer than 250 students.
Oh, this is great. I'm definitely going to have to use this.
Yeah. So all three of this combines together allows you to see middle schools and high schools that have fewer than 50 students. Or again, you can take any of the other variables in here. Is it a magnet school, the student-teacher ratio combination? So of the schools that are middle school and high school and have fewer than 250 students, which ones have fewer than 13 student-teacher ratio in that process? So the filters are neat in that function. And then, of course, with points, you can customize the icons, allowing you to change the things like the size, the color, and the shape. And this comes into play if you wanted to show multiple point data sets. So if you want to find out of these schools based on your category, maybe where they are in relation to a hospital, you can put a hospital data on the map. And then you can even be more specific and say where they are in relationship to maybe a children's hospital. And then this allows you to make a really cool data set. Well, you only have one children's hospital, but you get the point. So the ability to overlay multiple point data sets allows you to do this cool analysis of seeing relationships of different point data sets.
Yeah, wow.
And then, yeah, if we put one last thing on the map, which I'll just put a really simple data layer, which is income. And then from this, once you have a map kind of situated, a lot of times professors do this live. It allows them to, as you can see, present data in a really cool way. That's as you do custom ranges and custom filters, it really does bring in the audience a bit to explain how visual data can be. But then for a student, this allows them to then, if they make these maps for work or classwork, they can then export these maps and then save them into either a Word document or PowerPoint and such. So the print's really neat. This allows you to do a couple things. The one important thing that's really for our academic users is the ability to customize the title, and this allows them to put their information, their coursework, so it allows it to individualize the export.
Which button was that you clicked on to do the export your work?
Oh, sure. It's the print icon. It's a little printer icon on the right. You'll see there's a whole list of icons. You can do things like save, share, and download.
Okay, gotcha.
Yeah. Yeah, and the print's neat because it's basically the visual you see here is exactly what you're going to export. So the map is fully interactive. They can still zoom in, but exactly what they see in this map is what they're going to export then.
Neat.
So that's kind of the basics of the map itself. There's some other really cool underlying features, but let me know if there's any questions you might have right now before I go anywhere else.
No, I think we're good.
Cool. All right. So there's two really cool things that I definitely want to show you, and it's really about how to use the tool. So the single layer map is really for us the ability to kind of work with one data layer at a time and present that data layer. But there are times where our users, in particular our researchers, they are looking to do some pretty cool spatial analysis, basically being able to overlay multiple data layers and start seeing how those data layers might intersect or interact with each other. And so we created this multi-layer map function that allows them to do just that. So I'm going to do something simple, and I'll put income on the map. And so the way a multi-layer works is much different than single layer. Single layer, if we go there now, the goal of single layer is to show you all these different colors, and each color represents the different ranges that are in the legend. But with multi-layers, it's one color, and the one color, the user gets to determine what that range is on the map. So they can say no more than 70,000, and now the map will show you only places that have no more than 70,000, but at least 2,500. And so they can really make these numbers up themselves. We can bring this up to 30,000 and bring this up to maybe 85,000. So now only places that meet both criteria of 30,000 and 80,000 household income. And then from this, they can start adding another layer. So we can say of these places that have these really specific income ranges, Maybe we want to find areas that have don't have a lot of people with health insurance. And so now we add a next layer onto the map. It's also at 100%, but we're still within that first range. So same thing here, we can play with this number and say we're looking at places that have at least 7% of the people that don't have health insurance. And so now only places that meet both criteria. And you can do this up to 5 layers. And the goal of this is for users to keep adding layers and keep adjusting the ranges until they're finding places that meet the very specific intersection of that data. And it's a really powerful tool that allows researchers to identify places that they're trying to work in based on the various specific criterias. So this query is sometimes what is called an AND function. So it's only places that meet both income and uninsured population. But then we also realize that as a researcher, you also need to understand the edges, the places that might meet the secondary overlap. And so the OR feature is what they can switch to. So the AND is the intersection and the OR is the overlap. And so from this, they can still see places that meet both criteria, but now they can see places that meet just one criteria as well. So the benefit of this is it allows them to start seeing the surrounding neighborhoods and maybe the reasons why that surrounding neighborhoods might not meet the same criteria that you work in. And they can add multiple layers to this over and over. So the really powerful part of this is adjusting these numbers to get very specific in their query, but also adding more layers so they can start understanding other factors around the neighborhood itself. Cool. And then the last thing I'll show you is, unfortunately, in the legacy version, because we're actually just finishing it right now, but it'll be the same bit of interaction, and that's the ability to download data. That's something we definitely understand that our academic users are trying to use. So the maps page between the single maps and the multi-layer maps, the goal of that is to give users this platform to be able to add data, manage data, and then really customize it until how they want to present it. But we definitely understand there's a time where our academic users in particular are looking to download that data for a particular place to be added into their own analysis and application. So it's for now in the legacy version of PolicyMap, but it'll be in the new version. And the way it works simply is you can do a couple of things. The first thing is really to add data to the map. So if you want to do something simple and say, we want to get the total number of households that don't have access to the internet at all. Add the data to the map. We'll do something simple. We'll start with this data in particular, but the download icon up here allows them to go through the sequence of downloading. So in this case, we're going to download the layer data first, which is the aggregate data, and it's the percentage of people that don't have a computer in their households. Step 2 is determining the area that they want to download for. So this is where they can say, I want to get data for the entire US, or I just want to get data for Michigan, or even make a custom region of that very specific boundary that they're working in. But once they choose the area, they can choose the aggregation within that place. So in this example here, we can get all the counties in Michigan, and then percentage of people that don't have health insurance, that don't have a computer in those counties. Or we can do every city and zip code and so forth. So I'll do city as an example. You can see what it looks like. And step 3 is a very simple summary of what you're trying to download, which is the percentage of households without a computer by cities in Michigan. And then this will give you a pretty cool file that then they can access to this. So this might take a moment to download, but in the meantime, as they do this, I'll continue and add another data set. And I'll do, oh, there we go. Of course, I have a lot of monitors up. Let me just get this loaded. And so this is a list of every city. This is really helpful for users that want to use our data in another spatial tool like a ArcGIS or QGIS. The FIPS code is the boundaries of code for the city, so they can join this to a boundary file from the census. But from this, they can get this is the percentage of people of households that don't have a computer in each city. So in the case of Detroit, it's about 17% of the households don't have a computer that would have access. So the cool thing is, the way the download works for us is, the way we built it is that it's a very specific download, meaning that users at any time can follow this link in the source of our data, and that will take them to the data directory page, which will give them all the information about the data, but then there'll always be a link to the raw data that users can follow. And then from this crazy page, they can download the underlying raw data. The great thing about this is that they have access to this data as much as they want. The only sometimes overwhelming part of downloading raw data is that it is raw, so the users have to really dig through that underlying data set to figure out maybe the parts that they're trying to download. And that's the reason why we built this much more specific way to download. So if we were to say, of these places is the percentage of people that don't have access to a computer, but we also want to get the number of people, we can flip this to number, go through the download sequence again. In this case, I'll stick with Michigan, and I'll even stick with cities. So instead of the percentage of households that don't have a computer, it's the number of households that don't have a computer for the same area, which is the state, and for the same aggregation, which is the city. And then the cool thing is, we can just do this over and over again until you have a bunch of files, and then you can basically join them together in Excel. And the commonality, the base commonality, is the FIPS codes that they can join from. Sometimes this file takes a moment to load. There we go. So in this case, the really cool thing is, because we are a database, the export will always be the same. So again, they can join this by using the FIPS code as the denominator, but they can also cheat like I do and just copy and paste. And then as long as the area is the same and the shape is the same, the columns, the order is the same. So you'll see that it'll match up exactly. Yeah, so the download's really cool. Probably one of the last things that's really cool about download, and I'll just show you, and then from there, if you have any other questions, let me know. But
Awesome.
Downloading layers is pretty simple. Downloading points is pretty simple. It's just, icons. You're just downloading the addresses. One of the really neat things we built is the ability to put those two things together, which is the ability to download points and layers together. So we were to say, let's say we go back to schools, and we want to say, of the schools in, we do Michigan, we can find out maybe how many students, maybe how many persons under 18 don't have health insurance in the zip code that each school sits in. So we were to join health data, and we put uninsured back on the map, and we have it by age. So this is 19 and under. So initially it defaults to percent, and we want to get the number. So again, we just change this to number. We can keep it at percent. We do multiple files if we wanted to. But now if we were to do the download feature here, so we can still download layers, which is the number of people that don't have health insurance under 19 and under. We can download points, which is just basically all the public schools in a given area. And then the third one is this fantastic function, which is the joining of points and layers together. So we're joining public school locations with an area that has people that don't have health insurance under 19. And so that's where we get to step 2. So define the area, define the shade by. I'll stick with zip codes for now, and then you'll get this really long-winded sentence, but it's trying to tell you they're going to download the number of people that don't have health insurance under 19 for public school, that the zip code that it's in Michigan. It's probably one of my most favorite downloads because this basically allows users to do a couple of things because they're joining those two types of data sets together. This is going to take a few minutes. There we go. So this one's a little bit different because the query is so complex. It isn't downloaded directly to the browser. It's emailed to the student or user, which also is something we'll explain in a moment. But in this case, this is a list of every school in Michigan, of course, the zip code that it sits in, the FIPS code, which then they can join, but more importantly, the number of persons under 19 or 19 and under that don't have health insurance in the zip code that the school sits in. So we've joined a point data set, which is public schools, to a layer data, which is uninsured population together.
Neat.
Yeah, and then the very last thing, of course, is the way our academic license works is that users can come in, and I'll just take us to UPenn so you can kind of see what it looks like. Oops. Users can come in and create their own workspace, basically, in that access. There's a custom URL for each academic license, and then users from there can either create their own information, and it's all we ask in that process, which is email and a password for themselves and first name and last name. And then once they log in, it'll be their own workspace that they can save work, share work, but more importantly, anything that's created from other users will be available for them to access in these various menus.